Have you ever noticed how a small photo frame looks exactly like a bigger one? Or how the miniature model of a building looks exactly like the real one? They might not be of the same size, but their shape is identical. This is what we call similarity in geometry. Today in this video, we are going to master similar triangles. Let's go. Two figures are similar if they have the same shape but different sizes. They may be small, large, or even the same size, but their shapes must be identical. Here, triangle ABC and triangle XYZ are similar triangles. This is because their shape is same but size is different. For any two triangles to be similar, it is sufficient to have same shape. We do not care about their size. If the triangles are similar, then their corresponding angles must be equal. This means they must have three pairs of equal angles. If so, can you tell me the corresponding angles which are equal here? Very good. The first pair of corresponding angles are angle ABC and angle XGY. They are equal. Likewise, angle ACB and angle XYZ, they are also equal. And you know, angle BAC is equal to angle ZXY. If there are three pairs of corresponding angles equal, the triangles are similar triangles. That means triangle ABC is similar to triangle XYZ. This is read as triangle ABC is similar to triangle XYZ. Please do not forget this symbol, which we always use to represent similar to. If the two triangles are similar, we use this symbol in math. You know, in congruent triangles, the corresponding angles as well as corresponding sides are equal. But here, in similar triangles, only the corresponding angles are equal. I know you have curiosity about the corresponding sides. What is the relationship between corresponding sides in similar triangle? Let's see through an experiment. Construct a random triangle ABC using your ruler and pencil. After that, construct another triangle PQR having equal interior angles but different size. In order to make the angles equal, we use our pencil and compass. First, we draw arcs at point A and B, and with the same arc radius, we draw arcs at point P and Q. Let's measure the width of angle A using our compass and make exactly equal angle at point P. Again, let's measure the size of angle B using compass and we make exactly equal angle at point Q. Here angle A is equals to angle P and angle B is equals to angle Q. Our triangles are ready. Let's measure the length of the sides. AB is 3.8 centimeter. Let's measure PQ, which is 4.4 centimeter. Now we measure AC. Length of AC is 3.4 centimeter. Let's measure PR, which is 4 centimeter in length. Finally, we measure BC and QR. BC is 3.2 centimeter in length and QR is 3.7 centimeter in length. Let's determine the relationship between the corresponding sides. Here I have kept the same two triangles that we constructed right before. In similar triangles, the corresponding sides are identified based on their corresponding equal angles. You know, angle A means this angle and angle P means this angle, they are equal. So, one pair of corresponding sides are the sides opposite to these equal angles. Means BC and QR, they are opposite to these equal corresponding angles, so they are corresponding sides. Likewise, angle B and angle Q, they are equal. And the sides opposite to them, that is AC and PR, are the corresponding sides. You know, if two corresponding pairs of angles are equal in any two triangles, then the third angles will automatically be equal. That means angle C is equals to angle R. So the side opposite to them are AB and PQ, which are also corresponding sides. And as I told you before, the corresponding sides here in case of similar triangles are not equal. So let's determine the relationship between the corresponding sides. Here I have made a table with corresponding sides and I will calculate the ratios to see the relationship. In triangle ABC and PQR, AB equals 3.8 centimeter and PQ equals 4.4 centimeter. If I calculate the ratio of AB and PQ, that means if I divide the length of AB with length of PQ, then I'll get 0.86. Do I get 0.86 again if I calculate the ratio of other pair of corresponding sides? Let's see. Here I've got AC equals to 3.4 centimeter and PR equals to 4 centimeter. If I calculate the ratio, then I get 0.85, which is nearly equal to 0.86. This is 0.01 less than 0.86. So we can call them equal. This is because the least count of our scale is 0.1. Means our scale cannot measure the length less than 0.1. And see, the 0.85 is only 0.01 less than 0.86, means they are almost equal. So we can call them 0.86. If I calculate the ratio of third pair of corresponding sides, do I still get the same? Yes, because BC is 3.2, QR is 3.7. If I calculate the ratio, I'll get 0.86. See, I calculate the ratios of all three pair of corresponding sides and I got the same value. And remember, while calculating ratio, I have kept the sides of first triangle in the numerator and sides of the second triangle in denominator. You can reverse the case, but you cannot put sides of first triangle in the numerator and second triangle in denominator in first ratio and the opposite in second ratio. That is not allowed and you will not get the same value. From this experiment, can you tell me what is the relationship between the corresponding sides of similar triangles? Very good. Their ratios are equal. Because we have got AB by PQ, AC by PR, BC by QR, they all equal to 0.86 means the ratios are equal. If I have to make a statement, then the ratios of the corresponding sides of similar triangles are proportional, means equal. So we can use this relationship wherever we are given two similar triangles. Let's jump into the similar triangles problem. If the given pair of triangles are similar, find their corresponding angles and sides with their name. I taught you right before how do we calculate the corresponding sides, right? In order to calculate the corresponding sides, we need to be able to identify the corresponding angles, means the equal angles. And here in these two triangles, the equal angles are clearly indicated. Let's write the equal angle first. Solution. And the corresponding angles are angle BAC and angle EGF. Likewise, angle ACV and angle EFG. They are equal angle. It is indicated here in the figure. And as I told you before, if two angles are equal, the remaining angles automatically be equal. Means angle ABC is equals to angle FEG. Once the corresponding angles are calculated, then we write the sides opposite to the equal corresponding angles as our corresponding sides. So here, angle A and angle G are equal, and side opposite to them are BC and EF. So we call them corresponding sides. And we follow the same technique to identify the other corresponding sides. Means the other pair of corresponding sides are AB and EG, because AB is opposite to angle C and EG is opposite to angle F, which are equal. And finally, AC and FG, which are the third pair of corresponding sides. See, here I have written the corresponding angles equal, but I haven't written corresponding sides equal, because these are not congruent triangles. These are similar triangles. And in similar triangles, the ratios of corresponding sides are equal, but not the corresponding sides. Let's jump to the second problem. Find the measurement of XY and MG in the similar triangle XYG and MNG from the adjoining figure. Let me set the similar triangles. So this triangle and this triangle, they are similar. So we need to find the length of the unknown sides, and we'll be using the properties of the sides of similar triangles. To use that, we need to identify the corresponding sides. And to find corresponding sides, we have to find the corresponding angles. Means three pairs of equal angles. Let's find the corresponding angles first using our logic. Look at here. In these two triangles, this angle and this angle, they are equal, right? Can you tell me the reason behind it? Very good. They are vertically opposite angles. Likewise, this angle and this angle, they're equal, right? Can you tell me the reason again? Very good. They are alternate angles. And the third pairs of angles will automatically be equal. No need to write the reason, okay? We identified the equal angles. Once we identify equal angles, then we can easily write the corresponding sides. Can you tell me the corresponding sides here? Can you guess? Just the sides opposite to equal angle. Means the corresponding sides of XY is, XY means this side is MG, because these two angles are equal and they are opposite to these two angles. Let me write the given information, okay? In the given figure, xy, we don't know, mn 5 centimeter, xz 12 centimeter, nz 6 centimeter, yz 8 centimeter, and mz we have to calculate. And I have written the corresponding sides in order here. xy and mn, they are corresponding sides. Likewise, xg means this side, and ng means this side. They are corresponding sides, right? Because xg is opposite to y, angle y is equal to angle m, and the side opposite to angle m is ng, means they are corresponding sides. Yg and mg, they are also corresponding sides. Since triangle XYZ and MNG are similar, their corresponding sides are proportional. Means the ratios of corresponding sides are equal. Let's replace the values. Here we are given MN 5 cm, XG 12 cm, NG 6 cm, and YG 8 cm. But XY and MG we have to calculate. Let's solve it. We are given three ratios, they are equal, and we have to calculate two sides. Let's take only two ratios, okay? And while taking those two ratios, make sure that one ratio contains the unknown side that we want to calculate, and another ratios contain both the known side. Means here, if I take the first and second ratios, xy will be there and all others will be the numeric value. If I take first and third, then there will be two unknown sides and we cannot calculate it. Okay, let me take first and second ratios. That means xy by 5 equals 12 by 6. Now let's solve it. This 5 goes to the right side and multiplies with 12. So I'll get xy equals 12 times 5 divided by 6. And 12 times 5 is 60. And if I divide 60 with 6, I'll get 10 centimeter. I got the first answer. Let's take the second and third ratios. Okay? So the second ratio is 12 by 6. Third ratio is 8 by mz. Now we do cross multiplication, means this 12 mz multiplies 12 and 6 multiplies 8. So I'll get 12 times mz equals to 8 times 6. And I know 8 times 6 is 48 and 12 goes to the right side and divides, right? So what do I get? mz equals to 48 by 12, which is 4 centimeters. We got our answers. Let's summarize the video. In this video, we learn that similar figures have only the same shape. We don't care the sizes. We use similar to symbol to represent the similar triangles. Corresponding angles in similar triangles are equal. Corresponding sides in similar triangles are proportional, that is equal. And we solved some numerical problems. If you want more practice, download the worksheet linked in the description and keep practicing. Don't forget to like, comment, and share if you enjoyed learning with me today. Look around. Where do you see similar triangles in real life? Share your thoughts in the comments.